Hi, everyone. Welcome to another episode of the Common Lisp Study Group. I'm your host, Ram Vedam with Atlanta Functional Programming. Today, we're going to continue our discussion and exploration of the trivial extensible sequences library. Last week, we covered the majority of the library. There's a couple of few tidbits, though, that I thought we'd cover today. So, this might end up being more of an exploration episode than one where we're doing any distinct deep dives into any particular things. To begin with, though, a couple of notes that I'd like to mention for folks who are just joining in, who are interested in experimenting with this library on their own Lisp implementations. Like since last week, I have been actually trying to get trivial extensible sequences running on Clojure Common Lisp or CCL. For one reason or another, on my Debian 11 machine, I was unable to install the latest version of CCL to see what's going on. I'm getting some sort of kernel panic from the Lisp implementation, not from Linux, when I try to install using Roswell. For folks who may know some particular issues, I'm still digging into it, who are willing to provide some stuff, post your uh, updates into the comments in YouTube, and I'll provide a follow-up episode kind of explaining some of those limitations and or issues with the current version of closures and what folks are doing to address that in order for them to actually run Clojure Common Lisp. Now, this only affects most people who are running Clojure Common Lisp on Linux. I have not yet tried running it on Mac because I know Clojure Common Lisp tends to have more support on the Macintosh platform, given its pedigree and its history. It originally started out in that platform, so there's a lot more support and a lot more stability in that than on Linux, is my understanding. Of course, I'm more than happy to be corrected if I'm wrong. That said, uh, for the most part, if you're able to get this up and running, most of the examples that are provided in the documentation should work out of the box. So a lot of the stuff that we're covering today and what we covered last week will actually be applicable to the work or whatever experimentation you may be doing on Clojure. I have not yet tried installing Clasp yet. This is something that I've been meaning to do. This is and given Clasp's different distributions inside Common Lisp, it becomes a little bit uh, difficult to determine which one is the release and which one is the development because um, there's Clasp and Claspin. If you try running list versions on Roswell, I'm not entirely sure which one is just about. I'm assuming Claspin is just the latest release, but I could be wrong. That's kind of where we're at. See if I can get this up so I can show some of this stuff in at least another thing. I'm running Roswell in the background instead of my current Emacs session just so that I get full power of the shell. And hopefully once that gets installed, we can leverage that later on. Last week when we covered trivial extensible sequences, we had this running trivial example of using trivial extensible sequences. Sorry for using trivial multiple times. And that involved really creating this value as a sequence. So you have a single value, but you want to use the sequences library to what you leverage the sequences functions that are already available inside your Common Lisp implementation. This may or may not be something most people would do. I mean, this can be treated like an identity if you think in the Haskell sense as an identity value for what eventually is a list. But it's for the sake of the actual example itself, it allowed us to actually very quickly implement some of the basic overrides. And remember from last week, additionally, and that is, specifically for using the actual sequences library, at the very least, you had to implement these kind of 5 methods. length element, adjust sequence, and make sequence light. And with element or ELT, the one thing that would throw a lot of people off coming into and using trivial extensible sequences as their first Common Lisp library, and in fact, just after learning Common Lisp, it takes a little bit getting used to, is the fact that you not only had to override and implement element as part of the protocol, you also had to implement the generalized expander so you could set F elements inside of a collection. So this is a very important thing to just keep in mind. In general, a lot of the basic best practices when it comes to setting values is that you don't define your own setter. You write a set F on your getter in this fashion, and the Common Lisp implementation will know to call this function after parsing. The rest of this is just implementing kind of the primitives that all the other sequences functions end up leveraging, mainly adjust sequence and make sequence like or for construction and resizing, if you will, um, the uh, the actual sequence that you're dealing with. So adjust sequence is particularly useful if you're creating one-dimensional vectors or through make array, and you need to increase the size of the actual vector. Although, if you say adjustable true, it would do that through this adjust sequence automatically for you. Just to keep that in mind when you are going through um, implementing these methods. We ended last week also with the implementation of make sequence iterator. You know, the uh, override well, I would say the make sequence iterator is so that you can actually implement the iterator protocol. And this override basically just allows you to return, has multiple values, various lambda functions that would allow you to do everything um, from one second, from actually stepping through the function, providing elements on when to stop generating values inside of a sequence to getting the current value of it. And additionally, it gave the iterator protocol. This is so that you could actually implement a lot of stuff using the iterators. You could simply write a simple read write at the bottom like we have here, and and the last two obviously is the indexing functions and the iterate. How do we copy the specific iterator that we're currently at? Now, with value as a sequence, this is actually something that, since it's very trivial, since we are dealing with a single value, obviously, these last two, line 51 and 52 in the code that I'm actually showing, uh, they're pretty useless. So I thought it would be somewhat interesting to define, kind of an extension to this, a higher level of this, and that would allow me to introduce you to two other functions that were inside of the sequences iterating API that is part of the library. That for whatever reason is, if you look at the actual main documentation, it doesn't actually mention it, but uh, actually it mentions it, but it doesn't provide an example, and that is with sequence iterator and do sequence. And these two are particular ones that I thought we'd want to maybe at least experiment with and see what we can come up with. So that's just a quick overview of a review of what we did last week. So let's get started on, kind of implementing, something that would allow us to implement or leverage with sequence iterator. I'll actually try in using the current value as a sequence right now, just for the sake of example, but then um, I'm hoping to introduce to you, like I mentioned last week, generator sequence, which is experiments that I've been doing to see if I could write generators that would leverage the sequence library that uses trivial extensible sequence rather than what we've encountered in the past where you were using some explicit common Lisp library that defined its own object protocol to implement generators. And I'm thinking of not necessarily series, although series I think actually does implement generators at somewhere through scanners. But certainly there are one or two libraries I've mentioned in the past that allow you to implement generators. So let us try. See this. Shirakumu. I'm gonna, for the sake of today, since last week I mentioned to you that um, for whatever reason, I rather not use the package local nicknames to actually shorten this. But for folks who are on Jitsi, as well as in YouTube world that are uh, competent that they are going to be, well, not competent, confident that they are going to only use SBCL or any Lisp implementation that implement package local nicknames, and I know there's only a handful of the many active implementations that are out there that implement that. You are most certainly are welcome to you create a shortened nickname for your libraries. Just beware that not all Lisp implementations implement package local nicknames, so you could get bitten by it if you don't put the appropriate implementation guards around it. So now that we have our iterator protocol, we would like to be able to leverage this, right? When we're iterating through something. Okay. So I think it will be better if I create, it might be better if I create a list as a sequence, but I'll build this up to it. So to leverage this, we have to first go ahead and call out with sequence iterator. And what this does is as you see here, um, it's actually uh, requiring various uh, implementation things that you need to provide. What's interesting here to note is these all are actually optional. Iterator, limit, from, and what have you. Ideally, you shouldn't have to leverage this to actually implement the act to use the actual iterators. It will just call the make sequence iterator for the particular sequence type that you're dealing with, and then it will generate these for you as values, which is why these are optional. Um, but you do need to specify the sequence that you are dealing with. So let us first do this. Let me go ahead and create an instance. Let's do this in our proper Lisp fashion. Um, do I have? Don't need to do make sequence light. We could actually possibly use that. Okay, so let's do this. Did I type that in wrong? Yes, I did. Org dot dot. And let's do make sequence like, and let's create our sequence. Oh, right. because I can't use make sequence like because I don't have an existing sequence for this doing that. Let us do instead just a straight instance call sequence, and value is, let's say, 5. Okay, now we have our sequence. Let us put seek, val seek. Okay, now we're just going to, for the sake of this example, not do anything specific yet. We might actually end up, I did, because what I want to first do is do a macro expansion to see if the override gets called to implement these in the mini buffer. You might not, if you, for folks who are on the stream, may not, it might be difficult unless you do full screen, of course. But in the mini buffer, you'll see that there are a bunch of functions representing all the stuff that we defined earlier in our make sequence iterator. And I just want to see if they get assigned because they are optional arguments here. So give me just 1 second. Let me see if I do a macro expand. What happens when I do a macro expand here? Too few arguments in val sequence to satisfy lambda list. Okay, so I may have to actually name these. Okay, let's do that. Oh, I may have to provide an empty list. Let me see if I do that. Ah, there we go. And it will call SB implemental make sequence iterator. Yeah, so this will already generate what we expect it to do, which is it should call out to this guy and get our functions for us. So let us collapse this guy and so in here we know we're getting an iterator. So let's just do this, print iterator val seek, and then we need to provide state and end, because this is already generated for us if you saw this. All right, so this should just work. Because I'm going to have to do a fun call because of the fact that the function that we're getting is actually, so iterator is a closure, right? So it should actually require you to do an iterator fun call here. Let's see here. See what happens. State is unbound. Oh, right, because I'm trying to, these are all limit from state. Oh, I think I have to actually call value on this guy. Give him, and from end, I have to provide. So here, let us do this. Instead of, let's go ahead and do, let's call state being value sequence, which means this now has been promoted to a let star. And now we do from end for the time being is going to be set to nil, because it's actually technically irrelevant for this, because whether we do from end from the other way or from since we're dealing with a single sequence, it doesn't really make much of a difference. So let's see what happens if I do that. So this value seek is, oh, oops, made a mistake here. Iterator is undefined because I did not set this up. Okay. Well, then in this case, what I'm going to probably have to do is, let's see, let us see if I have to actually explicitly call this. Okay, and so that folks can actually see this, let's do that. Okay. Let's see. Sequence with errors with no. Okay, so I have to do a destructuring bind here. So it looks like we do need to specify these names in order for us to actually leverage this. Hold on, it looks like I have a comment here. Oh, yeah, okay, that's fine. All right. So a lot of times when we're going through these libraries, what I see in the documentation, what I've played around with, isn't what I end up seeing in this. And some of this examples, I didn't get a chance to play around with the sequence iterator before today's discussion. So I thought I may as well do it live. So my apologies for folks who are looking and saying, what is this guy doing? Let's see here. Let's see. And okay, hold on a second. Let's see this. Let's read this. Executes the body of bars. Let's look at the documentation here. Execute the body with the elements of bars bound to the iteration state returned by make. Yep, that's right. So I have to specify all of these. Ugh. See this element, set element, index, and copy. 2, 3, 4, 5, 6. So we don't need this. We don't need this because this is going to be generated. Limit from NP. Step NP element, set element. Okay. Let's see what happens here. Odd number elements in key value list. Okay. 3, 6, 7, 8, and 9. Okay. So what is the problem? Oh, got it. I have to provide abort from here. Start 0 and length val sequence, and from end, let's say true. Did I mess something up here? Odd number of elements. Hold on. Let's see here. I'm just reading through what this means exactly. This is saying that the key value list is going to be odd. What key value list is it speaking of? We have start, end, and from end. Let me try something here. See what happens. Oh, val sequence unbound. Hold on. Let me go. So when having problems, you always go back to the REPL to try out your things. It's kind of what I go with. Let's see. Oh, okay. Let's do this. So now we do what? Oh, this and that. Let's see what happens. So this is giving me what I expected to. It's giving you all the sequences. So what is it complaining about up here? This is basically saying that there are in with sequence def macro, val sequence start keyword list. I wonder if this is causing an issue with this guy, and it's just not telling us. So here, there looks like there is a problem with. So there's no problem with me calling make sequence iterator, but it's a problem with the with sequence iterator binding to those functions, which I am curious as to why. Let me see if I need to do this. This is before I know that I mentioned that I had to, but it didn't look like I needed to earlier, but we'll see. Odd number of arguments of fun call. State. We're getting a little closer. Let me see something here. Okay, we need to build this up here. Let's take this guy out, which is, and let's see if we can macro expand here. Let's say parsing arguments to satisfy lambda list. Okay, expecting 2 got 1. So let's do this. Let's see. Odd number of values in key value argument list. Oh, okay. I see what the problem is. I don't think it's liking the fact that I'm trying to call this function here. What I may have to do is make the list of values inside the let statement. So let's see here. Okay. IT protocol. Well, let's say iterator list. We'll just say, yeah, iterator protocol. Because technically this is what that is. Okay, go here and cut and paste. And we will go here and I'm just doing some formatting just to get things clean enough. Okay, hold on. Okay, let's see what happens here. Invalid number of arguments to satisfy lambda list sequence key from end. From end start end. Expected one got non-list. Oh, okay. Now we see what the issue is. This is actually, instead of us explicitly calling this guy, I have to actually pass in, like all other existing sequence iterators, the arguments. So here I have to do val sequence, and then I have to pass in the keyword arguments. From end, key, start is optional. But if I'm going to provide end, I'm going to have to also do start by default. It is also there. Let's just do start 0 and length val sequence. Invalid number of elements in val sequence. To satisfy lambda list, at least one is expected, but got non-list. Maybe I don't need to specify these three. Okay, hold on. There should be one thing here that would make things easier. Let's see. Sequence. So it doesn't look like with sequence iterator is liking the val sequence that I provided. As a result, it's complaining that it got a non-list. Oh, dummy. There. That's right. I'm okay. So here we go. So now let's do this. Print iterator. We have to think I can't just simply call iterator on this and then do hold on. What is this called? Give me okay. We'll just try this. Fun call iterator valseek state is been defined by what now? It is being defined by step. So we need to provide step of valseek, and we need to define in here the from end. So from end. Let's see if this works. There's a compile error here. No dispatch for. Oh, dummy. That. From end is unbound. Let's see here. That's not bound. What is it? It's probably from end. There should be no reason for us to actually having to do that for now. But we could certainly try that out. From end P on val sequence. Now, a lot of these are going to probably end up requiring us to, when we try running this, calling fun call even into them. I'm using fun call for the time being just mainly because of the fact that I didn't remember don't think fun call works on allowing you to like take a lambda like this. You can normally do this kind of like this, all right? But if you have a lambda xy, I think this complains. No, it doesn't. Okay, so I can actually do this. Let's do this. And let's see what happens. From end P, not defined. It's defined in the iterator, dude. Okay. Sequence 5. Make sequence iterator nil. Okay, so it expects us to do this. Iterator, let me see. step from end P. But this is multiple value bind, so it's going to probably complain. Okay, let us do this. Let's go through all of them. Again, what were those 9? Iterator limit from NP, step NP. So those are 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, what are the other ones? Then you have element, set element, index, and copy. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. That's it. Let's see what happens. Okay. So I'm going to have to use, it's not liking the fact that I'm trying to do this. So if I do this, not function, fun call, there we go. Fun call, fun call. Invalid number of arguments. Place function with the same arguments. Which function is it complaining about? The macro name step was found as the argument to function. So this was treated as a macro and not as a closure. That's interesting. Let us do this. Hold on. And that's the reason why we were having a problem. I didn't realize that this is the issue. Okay, so I have to rename this guy. I forgot that step is actually going to complain about the debugger. So step is a reserved keyword. I was just looking at what the documentation provided and ended up ignoring that fact there. Okay, so let's see if this works. Okay, state is also undefined. Of course it's undefined because these are all functions being provided to us. Invalid number of arguments. Oh, I have to really pay attention to what we provided now for the limits. Okay, so for our step function, we have provided 3 arguments, so we're good with this. That's our first one. Our second one is going to be the from end value, which is, let's see here, number 3. So this is our iteration state, our value describing the limit, and the from end. So from end itself is actually it's not a predicate. It's actually it's actually a non-function. So, and then we have our step function, which we now renamed as state. So we're calling that right. So let me do this. Okay, our step function is our state function. Then what is our oh, right. Let me do this. I'm messing up the ordering of the values that are being returned by the function because I don't have key value pairs here, right? So I have to map what's in here with what we just defined here in the order. So this is our first argument. This is our limit, and this is our from and p. Let's see if this works. Okay, there we go. There we go. And now, obviously, because we're not using all these other functions, we have an ignore that we have to provide to get rid of this warning. But I'm not going to do that. Let me do this. Let me go instead format t, so that way we can look at our limit max it, our from end. This is our first argument that we saw earlier. And then now we can actually call the function. So let's say first iteration. And then let's call state on our val sequence. And here, since in the first argument we have to do pass in from end, we need to also technically do what was the order? It is the val sequence, the iterator, and then the well, technically you don't want to do iterator, you want to do value of the val sequence. Because what you're asking for is the element that's in there. So what really you need to do is do this element of the val sequence at the iterator. Hold on one second. For some reason, my mini buffer is not giving me what I want. But let's see. Forgetting the ordering right now. I think it's ELT sequence and then index. So we do this. Max it is not a string. Oh, right, dummy. I gave the format string, but forgot to provide standard out. That. State is undefined. Again, state is not undefined. It should be defined. Oh. Let's see this. Hold on one second. It's not liking this this call to the closure. So I'm wondering what's happening here. Let me look at the macro expansion here before we get started. Before we continue. Let me just see what happens when I return state, just out of curiosity. And state is nil. Interesting. Why? Let me try renaming this guy. Maybe it's not liking the fact I'm calling it state. Hold on, I need to. Okay, so we get 5 style warnings, but it doesn't actually give us anything about what these values are. So what I'm going to do is I'm just going to return these as values just to show that these elements are bound, and then we'll continue on with our discussion. Uh, See, we do have a function here. Interesting. So I should be able to call this guy. Let's do this for this sake, and let's do format t iteration 1 fun call stp, and we know that we need to pass in value of a val sequence, and we need to pass in from end. So let's do from end p. And see what happens. Invalid argument 2 for calling the function. Interesting. Oh, got it. I need to do I see it in there, but it says that it's invalid arguments. So let me do something here. Fun call lambda. Maybe I'm messing up fun call, so thought I could just do that, right? And then let me do what I did earlier. Y3. Okay, so this is right. Oh, val sequence is the first argument. There we go. Now we got it. So in this case, the step function is incrementing the function, if you recall, right? So here, sorry, thank you. Here in line 41, we have a function, the closure that actually 39 to 41, we define a closure that takes in the sequence that we passed into make sequence iterator. And we are just ignoring the sequence for the time being, because again, this is just the value as a sequence, right? We grab the actual underlying state and we just step into it. Now, ideally, what you would want to do in this case is instead of passing value as a sequence, you should be able to just do, what is it? Internally, it takes that state, which should be the IT, and we grab it inside this function. So let's go ahead and change this. So we're going to give you the iterator, which is the index into the actual sequence. And in here, let's go ahead and actually correct this so that we actually leverage our values correctly, right? We're actually implementing the iterator protocol, and we're hiding the fact that how we're accessing the actual underlying collection inside the actual closure itself. So here we correct this. We change this to being val to being the ELT, given the sequence and the state, and then we return val. Now this should update, and now we have an error. What is here in this warning? Style warning starts, never going to be used. Okay. Okay, and now we corrected this, and again, we're going to go ahead and clear our REPL because I hate warning messages being inside of my REPL. And let me also, for folks who are watching this, let me increase the font size a little bit. And we go do this, and we still end up getting the same issues. Now, we're still getting warnings because of the fact that I bounded more than what I'm actually leveraging. But if you define one, you technically have to define them all. So ideally, what you would have to do in this case is just simply do a declare ignore, and then specify here all these guys minus that, and we're good to go. Okay. Now, I'm a little disappointed. Let me see if I can actually complete this example by getting rid of this. So this way we could just call it directly. I doubt that this is going to work, but we'll see. Yeah. And the reason why it doesn't work is because even though this is a lambda function, okay, and we saw earlier that we could actually call lambdas with arguments. Unfortunately, it's not bound to a symbol that is whose symbol function is set. So let me I'm going on a little bit of a tangent, but it's important for folks who are watching this to have a good review on what this is, okay? Because we've talked about this before once when we talked about functions a long time ago. But just to kind of rehash that concept, um, all symbols inside of Common Lisp implementations are part of two different namespaces. Okay, so when a symbol is defined inside Common Lisp, that's defined as a function. Let's take a simple example, like if we do defun hello world, no arguments, print hello world. Okay, so here, if we actually look up the symbol function of hello world, we'll end up getting the actual function, okay? And there's two types of symbols. There's symbol name, symbol package, symbol values is actually what the other case here, okay? Here, just to show this to you guys, and which will ultimately show you why this is when a Lisp function is defined and returned from a macro, it actually assigns itself to the symbol value, not the symbol function. Okay, so if we look at the value of step, okay, and we do symbol value of step, okay, and then we look at the function of step, and let's not say step symbol here, ip symbol here, okay, and here we call function, and let's make sure that we pass in the symbol accordingly. When we go and run this, oh, right, because these are symbols already. Hold on. I don't think we need to do this. And So you can see here already that step is treated like a function, but it doesn't actually have its value set. The object itself is not actually a proper symbol object that you can end up make it fun callable. Okay, so this here is also a problem. This is why you're both of these are actually getting called. This generated symbol that's being used inside of the macro is one that isn't actually completely bound. It's a bound variable, but it's not something that is a bound symbol that's inside of the image. Okay, it's lexically scoped, and as such, its symbol information is incomplete, so we can't leverage um, other parts of the Lisp machinery as we would normally, kind of expect it to. So this is why here we were able to do what we were able to do um, in these examples, but we weren't able to actually do the same here with a bound variable. Okay, so that's with sequence iterator. Sorry for that little debugging session, but sometimes that happens. Um, The other thing that I wanted to show you was with do sequence, because do sequence is kind of the same concept. Um, Except it's even simpler in terms of its notation. Let's take this guy back here with our sequence. We could then do org dot shirakumo dot um, trivial extensible sequences do sequence, and we take an element, let's call it um, el, and let's say our sequence is value sequence, and um, it will already bound itself to the current iteration, so it hides all the all this stuff here that we're seeing. And if you're just trying to limit yourself to implement going through a specific sequence, you could certainly use this instead. And it does the same thing. And you can see here that it compiles. Let me say something. For some reason, it's not printing out my value. Let's see what happens here. Compile and loaded. Why isn't this not actually showing up? Oh, it's saying that it's nil. Sorry. It's because it's at the end of the sequence. Because there's only one sequence and the iteration is max. It's not spitting out the current value of it. Which is return, which is interesting. This should have actually provided us at least one value. The fact that it doesn't bothers me a little bit, but let's see what's going on here. Okay. It's grabbing, so it does a do list on nil. Interesting. And set val sequence, but so it's running do list, and do list is probably using ELT, and ELT is probably using other things. Ooh, I just learned something today. We can actually fix what we did earlier with this. Oh, nice. Okay, this is nice. Sometimes this happens. This you learn a lot of stuff when you do macro expansions, right? So apparently, to avoid this call to fun call, I can simply say declare function stp. Let me see if that works. That looks pretty cool. SDP is undefined. Huh, nope, that's not true. So what is, now I have to see what this guy actually does. Declare function. Oh, it still ends up doing fun call anyway. Yeah. All right. What's the point? I guess the declare function is for hinting to the compiler to do some optimizations related to function calls to reduce the number of function calls. So in places where you can probably do inlining, it certainly allows you to do so. Mhm. Interesting. Okay. So there's one issue here, remaining issue that for do sequence, it seems to be doing what it's expected, but um, this here is why we're getting a nil. Is more than likely why is the more likely candidate. So let's do something here, which I didn't think I would need to do, but it's a good, interesting experiment. Okay, but let's get this guy, paste it. Oh, wait. Okay, and then let's do a do list ourselves here and see what happens. ELT val sequence and do print ELT. It's not of type list. And this is the reason why this shouldn't be working. Okay, this is interesting. I may have found something. Ooh, can I think I may have accidentally killed my Lisp session. Okay. Start. Wait. Switch up. Okay. Quick load AFP test workshop. Let's see. Nice. And then do this. Set package. Do AFP test workshop. And we're back in business. All right. Looks like it's doing something a little bit weird for I think, but I covered the majority of what I wanted to discuss today. So now we're in kind of an experimental thing. So we covered the API up until now. Apologies for some of the macro debugging. Didn't quite sure how things were getting bound there. Um, but now that we have kind of an overview of what the uh, sequences API does, extensible sequences API does, especially when we want to subclass sequences. Obviously, the example that was trivial is trivial for a reason, to allow us to make these kinds of mistakes when we are, and allow us to debug easier since we're dealing with only one value as subsequent of values to learn how the sequences API works is. Let's put this into somewhat practical use. I'm saying somewhat because of the fact that the example that I'm going to be showing now is something that I'm interested in looking at, um, particularly because of the fact that, in some cases for larger programs, it's often the case that you may end up encountering situations where certain libraries conflict with each other API wise. And so it's kind of nice to have something like trivial extensible sequences at your disposal where you can hide the complexity of how you're particularly retrieving something and allow your users to be able to use a universal API to actually get access to particular values inside any of those collections. So this way, any complexity related to a particular third-party library can be encapsulated inside of your generator object or your object, your sequence object in this case, and then the rest of your application developers are oblivious to how things are kind of going. So in this example, I was kind of working through this. We're going to kind of create a generator function. Um, but we're creating a generator function in the sense that it's going to act like a sequence. Okay. So obviously this is going to require some thought into um, the what it means for something to be iterated against when you're talking about generation. What is the maximum generation that you want to deal with when you're dealing with the fixed sequence? It could be the case that you want an infinite generator, in which case this may not be the API that you want to use because it's kind of expecting the sequence to end. This is kind of like infinite sequences here. Um, while certainly is possible, it's not something that was intended by the API because a lot of the generic algorithms that are provided as part of the Common Lisp API expect to be able to compute length, at least from our earlier example in the discussion that we had with the uh, the concept of implementing the bare minimum functions in order for you to use the sequences API, particularly length is one of them, right? So just keep that in mind. That said, there are some use cases where generators are very, very useful. Specifically, one that immediately comes to mind is if user extensible sequences were available across multiple Lisps, you could have implemented database cursors has generator sequences. That is one particular example. Here we're going to create using def class a generator sequence that takes in again like before. Here I'm going to just copy this guy since this is going to be exactly the same thing that we're doing here. Subclass list is always going to be the same regardless. So we need to subclass from trivial-extensible-sequences, sequence, and standard object. And in this case, you define a function here that's init arg. This has generator function. Generator function. And we're going to go ahead and also say our init form is nil. Okay. Our accessor, it's not going to necessarily be I guess we may want to make this into an accessor. Yeah. So we could, no, we want this as a reader because you do not want other folks, once a generated sequence has been defined, you don't want people to go and change the actual underlying function the generator represents, right? So you'd want to actually restrict that. So this is going to be a implementation here that doesn't allow changing the values. We're going to see how far we could push this example with the remaining time that we have. And hopefully this will give you an indication at some of the limitations that this library may have, or it might be that this is gives you some ideas for other thoughts. So here we've kind of implemented our basic guy, and now we need to go ahead and define the 4 methods. Okay, and for now, I'm just going to stub these guys out so that we can get this up and running, and then we will implement them one at a time as we go along. Okay, so again, what was it? It is, we need to provide extensible sequences, our length sequence. Oh, I'm forgetting. Need to always keep this on track here. here. Okay, and hold on, length sequence. And this is taking our seek, I believe, right? Let me go ahead and restrict this guy so I can actually look at each of these. And we're specializing this seek as our sequence has generator sequence. Okay, there we go. And we're gonna just throw an error saying not implemented yet. Okay, done. Oh, sorry. And we need to do this. All right. What? Oh, yeah, hold on. It should have been generated sequence. Okay. Next thing is obviously this guy and its setter. Oops. Okay, set F, and we are good there. And here we're going to go ahead and do this. Value has sequence. Well, we can actually say value as, and then replace that with generator. Okay, and again, really we need to do this. Oops, not that. Okay, and then finally we need to implement adjust sequence and make sequence like. And we do this, sorry, to value sequence, value, replace that with generator. Done. Okay. And here, do this, and here. Okay. So we now have our stubs all implemented. We will go ahead and go through this one at a time. The first one is the generation of the sequence. Now, there's a couple of ways of doing this. One is what do you want length to represent in terms of a generator, right? If it were right the case that you were doing something like, say, and you can make this all sorts of ways, right? I'm going to keep things simple for the sake of the example. It could be the representing the number of values that you've generated so far. It could also represent the number of cached values that you want to keep. So it might be the case where when you're generating some values, did you want to maintain for the purposes of quick analytics, um, like a sliding window of everything that you've actually defined, or you've retrieved, or you've computed. Here, I'm just going to go with, for the sake of example, just the number of values that we've computed so far, okay? And it will be easier to do this if I just simply go ahead and add an additional guy inside here called uh, not necessarily sides or computed values or something like that. All right. Uh, Computed values may be a better. Another name might be just say call size. All right. And we're gonna make this no init arg. Its init form is 0. Okay. Its accessor is just going to be Uh, its accessor is going to be just, we'll just make things again pretty simple. We'll just say collected, okay, um, or computed, just so that we know. Actually, generated is probably what. How much have we generated? It's probably a better value. No. Let's not try to make this difficult. Let's just go ahead and say it's size. Okay. Um, and this can represent window size too as well. But and this is kind of what I'm thinking of when I'm saying this. But for the sake of example, we're going to go with size. So we're going to go ahead and update this. I'm going to go ahead and update all these iterators. Oops. Requires 3 arguments. Hold on. What is this it's talking about? All right. So let's see here. What did I mess up? I overwrote stuff. Value as a sequence, and set of value. Ooh, okay, got it. Forgot. This needs also the value. Okay. There, and no class generated sequence. Oh, right. Okay. This is wrong. Do this. Do this. Okay. Do that. Do that. All right. Um, so for this one, length is pretty simple. Now that we have this value, we could just do this and say size of our sequence. Okay. Now, for now, I'm not keeping the collection. I'm just representing this as the number of values that we've computed so far in this generator. Okay. Here, when we're grabbing the element, we would like to be able to just simply call that function. Okay, so this generator sequence is assuming that the generator function is a closure. Okay, there isn't currently a way that I'm aware of to actually enforce that. Um, Obviously, if it would become required when a person is trying to use such an object right now, there should be some error checking during construction to make sure that we're able to call this with without any arguments, and then write a condition handler to essentially say, sorry, it's expecting a closure, please encapsulate your state to generate values. But I'm just saying for now, I'm going to ignore those error checks just to simplify things. All right. Now here for ELT for any index, what we basically want to do is do two things. One, we want to actually compute the value that's being returned, okay, by the index, okay. Um, and I will say that if users are going to, because this isn't holding pre-computed values, what we need to do is we need to add some safety checks here to see if the first time that it calls, it'll successfully call it. But the next time it calls, if the index is greater than the number, well, actually, if the index is less than the number of computed values we already computed so far, then that means we've eaten the computed value, and there's no way for the user to retrieve it without essentially reconstructing the object and recomputing things. Now, this makes generator secret somewhat functional in that um, it's the only time it ever allows you to get something is when the object is treated as a value and you're able to actually update the object. But at the same time, it's not idempotent. It's not an idempotent function, meaning that if you pass in the same inputs, you get the same outputs. Okay, so uh, this needs to be corrected for a proper, more robust solution. But I'm just going to go ahead and implement this for now this way, so at the very least you can at least see how this kind of generator function can work. Okay, so let's go ahead and do this, and let's set our value to be 0 here. And we're going to ultimately return the value. Ooh, sorry. But we need to first do our check earlier. Um, so what we do is do times it should be do times no. We need to first do a check. If index is less than size of our sequence, actually, let's put it the other way so we actually compute things. We should actually, we can make we could do it this way. No, we do want to throw an error for the end user. Let's throw an error saying generator has already computed value. Generator sequences do not cache previously computed values. And of course, you could change this this for the time, but I'm right now making this pretty straightforward for us. Now, if it's the other way around, now we can actually go in and say, okay, do times x, the difference between index and size of sequence, and that's the number of new values that we need to compute. And we're going to ignore this because we're not going to use this as part of our generator sequence. Again, remember what I said earlier, we're kind of assuming that it's a closure, and we're just simply going to do set f val fun call generator on, and that's it. And this should actually, because it's not going to take any arguments, it should just run. Okay, so this looks a little ugly. I want to clean this up. The first thing I will notice is I can actually simply make this a when and get rid of one layer of nesting here and here. Hold on. No, that's fine. So let's go ahead and re-indent. And we now have a semi-clearer thing. Obviously, this could be even clearer, but this can, this will make things a little simpler. What is it complaining about? Undefined function generator. Generator is not, it's a reader right here. Why is it still saying undefined function generator? Okay, so I'm going to try something here just very quickly, just to kind of show you how this all works. Let us do set f gen, well, we'll call it doubles. Make iterations generator sequence with the generator function lambda x let x0 lambda 1 plus x. And obviously we need to reassign this. So cpwr set f x1 plus x. And let us go ahead and return x. Now, this is going to eat the initial value. If you want to certainly return the initial value, you could certainly do though by several layers, but let's just make things a little easier for us. So this, see this, undo, oh, good. So set f without doing a def parameter will throw this warning message, but it does define it and set it for us. So now this is here. Let's go ahead and do, let's see, this is that. Let's go ahead and do an ELT doubles. And let's call it 2. Generator undefined. It doesn't like the fact that I named it that. Okay. All right. Okay. I got it. I see what the problem is. I'm using a keyword argument here instead of a. That's right. All right. Now we're good. This should actually work. There. So now if we call 3 here, it's going to, it'll run it 3, 4, 5. Interesting. That is not true though. If I do here 2, so there is a problem here. It's not recognizing because the call size is initially set to whatever. I forgot to actually do something here. You see, there's a bug here, and that is because every time we call this, we should actually increment the counter. So I need to do setf size. I think actually if I do 1 plus, it doesn't, if I do an increment size sequence, this should do the trick. Okay, so now let's do this again. Let's do this. 3, okay, 2, and throws up an error. You can see how this works. Now, for the setf function here, the generalized expander, since we don't want to necessarily, this is again a generator sequence, right? We're not setting f anything. We're not rewinding at all. You could totally just say generator sequences are not modifiable and just be done with it. And then these last two methods, make sequence-like and things, we can actually go and implement with the constructors, but I can leave that to you as an exercise. In the remaining 20 minutes, because the reason is make sequence-like and make adjustments. It's going to be very similar to what we did here earlier in this, so I really don't want to go through a repeat for that. For folks who are interested in the construction piece, just, I encourage you to go and look at our previous episode on the integer stuff. Although this is a trivial example, checking the types of the sizes and stuff is talked about already last week when we discussed this. So in the last 20 minutes, I'm going to open the floor to questions, see if there's any, questions and comments about things. And I will. Yes, Alex, go ahead.
Hey, Ram, I was wondering, when you just code day to day, do you ever use Copilot or OpenAI or ChatGPT to help you to supplement or to not supplement to complement what you're doing in Common Lisp?
I haven't hooked up Copilot with my Emacs editor. I would have to go in and obviously take a look into that to see if there was any particular ways of doing it. But
that would be a great idea to do, just because then, like, let's say for myself, when I'm, let's say, doing some sort of exercise, I can actually learn how to hook that up and get it set up from
okay, I can
yeah, just as an
certainly do an
idea,
episode to kind of like show people how to hook up Copilot to Emacs so that they can do Common Lisp editing with Copilot. That's certainly a good idea. I will certainly keep that in mind so that I could get that scheduled. But yeah, to answer your question, your immediate question, the answer is no. A lot of times, what I end up doing is especially when I'm doing these kinds of what's the word that I'm looking for? These kinds of exploratory discussions where I'm actually looking at the API. I usually have live coding sessions where I jot down only a few notes based on my understanding of what the API is saying, like on a piece of paper. But then a lot of times it's a live code. Okay, this is what I understood of the API. Let me see if this actually works this way. You know, um, and then you see me bumble through some of these examples. Just to see if there's an incorrect thing in the API description, or is it just my misunderstanding?
Great, thanks.
No problem. Again, actually, we have a
What happened there? Is that me or?
No, I think maybe there was a time limit, and Ron started like 2 hours ago as of this minute. Hey, Ron's back. Okay.
Yeah,
Okay.
yeah. Sorry. It just kicked me out for some reason. I must have accidentally exited something or pressed a button. Who knows? Let me.
I have a question, Ron.
Yes. Go ahead.
With the unexpected things that you've noticed, do you give feedback to what's his name? Shirakumo?
Yeah, Shinmera. Yes, I anytime I find something interesting, I try to come up with a bug list, and I try to report that back. Although last week's discovery on Clojure, I wanted to do some discussion related to um what's it I wanted to do some investigation related to what exactly is Clojure complaining about, because it was the error that I was getting seemed to be related to Clojure CL and not related to trivial extensible sequences, because I was getting a kernel panic when I was loading the Lisp up in the first place. Okay.
Yeah.
And because of that, I didn't want to
Yeah.
prematurely
Separation
report a
concern.
bug that turns out to be a problem with the Lisp. Okay.
Yeah.
Um,
Cool.
it's an important piece to know.
How about
Um,
today?
yeah. One thing that I wanted to demo finally is I do have now some ability, it looks like, for me to. We're going to try. I have Clasp installed, and it looks like Clasp is actually working. So I might be able to try showing this working with Clasp. Um, and it's pretty useful for folks to check out, to know that there is yet another Lisp that they could go and use and, you know, run with trivial extensible sequences. So if everyone is willing to entertain a few minutes, I can try and start another.
Yeah, I'd like it.
Yeah. Hold on 1 second. There we go. Sly. Start a new one. Okay, so this is starting, unfortunately, Lisp, SBCL. So let's do this. E shell. Okay, and let's do ROS -q to include quicklisp -l clasp bin run, and hopefully this will all work. Okay, excellent. Let's go ahead and load our workshop. Everything compiles. And the fact that it compiled and even loaded these values is proof enough that it's actually working. Like, I don't think I have to go through any of the examples to really iterate it through. But in case people are wondering, I can certainly also do that too. But I'd have to do, I think, in package test workshop to switch, and then we could try the example that we did earlier, which is with the generator example. Make instance generator sequence, generator function being let x0. Let's define a lambda x. That actually does the proper thing, which is actually add 2, because and you can see here doubles is going to be our generator sequence. If we call doubles 2, we get 4. Well, you should have gotten 4, but for some reason got 2. Doubles 3. Huh. Interesting. Hold on 1 second. Why is that causing a problem? Let's see. What did I mess up here in my definition? Oh, right, because I'm being dumb. I need to actually define this. I need to set F this. Do this here. No. Thank you. Okay, so now let's do that. Set F x plus 2. There we go. X. Okay, so now we have this. You can see that if I do doubles 2, you get 4. If I do doubles 3, you get 6. But if I try to re-access doubles 2, we'll get the same error before. Okay. So now I can you can start defining these things. I'm going to start leveraging this for some other future work, but I will start. I'm not going to. We have 9 minutes before we have to end today's discussion, so I will start telling you about our projects and next week's discussions. Next week, I thought for us to start doing some projects with some of the stuff that we've been discussing the last couple of weeks. Plus, it'll be interesting to note how to architect some of these larger systems. Hopefully, debug some of these larger systems. Particularly, I noticed that I can get some nice books from Project Gutenberg that I thought would be interesting to hook up to, say, a graph database and start playing around with, some basic, albeit trivial, natural language processing to kind of reiterate some of the stuff that we've covered in past episodes, as well as show you a real case example where you'd want to, encapsulate some of that stuff into a sequence type and then give your users a sequence API to work against, rather than having them write queries for particular things against the database. So I'm still working through the details on how to encounter that project. Might have to do some prototyping there, but certainly next week I'm hoping to present you guys with a simple discussion on something like that, maybe with a brief, albeit maybe experimental architecture that we can implement live. So you can again see some of the mistakes as I'm working through them and then provide comments. So until next time, I appreciate all you guys for joining, entertaining our debugging discussion earlier. And if you have any questions or comments, feel free to post the comments inside the YouTube comments. And again, as a reminder, as always, Atlanta Functional Programming is a meetup that promotes functional programming, not just Common Lisp, but in many different languages. We try to host monthly topics as well as our weekly Common Lisp study group. If you have a topic suggestion, feel free to drop me a line. I am Bugram inside the Functional Programming Slack and Tech 404 Slack. I am more than happy to schedule you if you'd like to discuss some stuff. And until next time, I'll see you guys later. Thanks.